Welcome back, everyone, for part two of our lesson on the section 1.7, the mixture problem. In our last video, we looked at a single example of how the process works, and here we have multiple examples. I'm not going to do them all. In fact, exercises 2 and 3 are kind of like the exercise that we did yesterday. So I want to take a look at 4, maybe talk through 5, and we won't do number 6. So that's kind of the agenda for today. So here's exercise 4. Tank whose volume is 40 liters initially contains 20 liters of water. So it tells you the size of the tank and it tells you how much water is in the tank. A solution containing 10 grams per liter of salt is pumped into the tank at a rate of 4 liters per minute, and the well-stirred mixture flows out at a rate of 2 liters per minute. How much salt is in the tank just before the solution overflows? All right, so here we go. So the volume of the tank is 40 liters. Okay, there's 20 liters of water in the tank, so the initial volume is 20 liters. The initial amount of salt in the tank is 0 because it's just water. A solution containing 10 grams per liter of salt is pumped into the tank, so the concentration going in is 10 grams per liter at a rate of, so Rn is 4 liters per minute, and the well-stirred mixture flows out at a rate of 2 liters per minute. So R out is 2 liters per minute, and C out, the concentration going out, is always the amount of salt in the tank or chemical in the tank divided by the volume in the tank. Now, what's the volume in the tank? We know that. It's the amount that you start with, which is 20 liters, plus T times the rate going in minus the rate going out, so 4 minus 2. Okay, so the volume at any given time is going to be 20 plus 2t. So I'm going to write that volume as a function of t is 20 plus 2t. Okay, m as a function of t is what we need to find. Because once we know what m as a function of t is, we can use that information to solve the problem. To know it, we'll have to appeal to the differential equation. dm dt equals Rn times Cn, so that's 40, minus R out times C out. So R out is 2 times m over 20 plus 2t. Okay, all right. So this is a differential equation that is familiar with these problems. We can solve it using the integrating factor. It's of the right form. As soon as I add this term over to the other side, so I have dm dt, I can call that m prime, plus 2 over 20 plus 2t, and that is going to be times m, and that is going to be equal to 40. All right, so what we have to do to find the integrating factor, okay, it's going to be e to the integral of 2 over 20 plus 2t dt. Be very careful as you go through this because this is a critical step that you get right. This is e raised to the antiderivative of 2 over 20t is the natural log of the absolute value of 20 plus 2t, because the derivative of the bottom, which is 2, is in the top, so it's a natural log integral what's important is that you get the coefficient right. Okay, so I did this problem just a minute ago, and I had the wrong coefficient right here to start off with. I had it as 1 and not 2, just because I made a bonehead mistake. But had that happened, okay, and this 2 was actually a 1, then there would be a 1/2 out in front of this natural log. And before you could cancel e in the natural log, the 1/2 would go into the logarithm, and it would write 20 plus 2t as a square root. Okay. If there was a 2 out in front, then it would be 20 plus 2t squared. Now that's two wildly different results that would really wreak havoc on your solution as you move forward. So make sure that this coefficient is correct. Make sure that you integrate this correctly. Okay, so all the work that I've done in preparation for the video is wrong because I'm off by a constant. So we'll see how this goes. So this is 20 plus 2t, and off we go. So what we do is we multiply the left-hand side and the right-hand side by 20 plus 2t, 20 plus 2t, and what do we get? We get 20 plus 2t times m prime plus the 20 plus 2t's cancel. We're left with 2m equals 40 times 20, so that is what, 800? Sure. Plus 80t. All right, now what's on the left-hand side should be the derivative of some product. That would be the product of m and 20 plus 2t. Okay, because if I use the product rule here, take the derivative of m, I get m prime times the second term, that's 20 plus 2t, plus the derivative of the second term, the derivative of 20 plus 2t is 2 times the first term, which is m. And that's going to be equal to 800 plus 80t. Now, at this point, I integrate both sides with respect to t. The integral and the derivative cancel off. You have m times 20 plus 2t equals, let's see what this is. It's 800t plus 40t squared plus a constant. And solving for m, I get 800t plus 40t squared plus a constant divided by 20 plus 2t. Okay, and so this is my general solution. Now, for this particular situation, we know that m naught is 0 because we originally started with water. So I can plug in 0 for m and 0 for t, get 800 plus 0 plus 40 over 0 squared plus c over 20 plus 2 times 0. So 0 equals c over 20. So c is equal to 0. All right. So the differential equation that the solution to the differential equation, or to the initial value problem that we're looking at, is 800t plus 40t squared over 20 plus 2t. There you go. Now, what did the problem ask us? Let's go back here. How much salt is in the tank just before the solution overflows? So when is the solution going to overflow? Well, the solution will overflow when the volume is 40. So when will the volume be 40? I don't know. Let's see. This will be 40, looks like, when t is equal to 10. So after 10 minutes, we have 2 times 10 is 20, 20 plus 20 is 40. The tank will overflow. And we want to know how much salt is in the tank just before the solution overflows. We can do that. So M of 10 is equal to 800 times 10 plus 40 times 10 squared, all over, well, we know what the bottom is going to be, 20 plus 2 times 10, that's 40. So that's 8,000. 100 times 40 is 4,000. Yeah. And divide that by 40, so we get 12,000 over 40. Looks like that is going to be 300 grams. All right, so you can't see that. Sorry about that. That is the solution to the problem, or at least, provided I haven't made any bonehead mistakes, is the solution to the problem. Okay, perfect. So as you can see, this problem, very, very, very similar to the one that we did yesterday in the first lecture, and the two that are above it. The only difference here is you're starting with water, so you have to be able to reflect that, okay, with the initial mass of the chemical in the tank to be 0. And it doesn't say how much salt is in the tank after 10 minutes. It gives you a condition that you have to use to find the when you want to measure the salt in the tank. Okay, so that's the difference between this problem and the ones before it. We'll take a look at number 5. We'll see how to look at both parts A and B of the problem. I don't know that we do the entire problem, because I don't know if there's enough value in having you watch me go through the algebra of it, but we'll at least set it up. A tank initially contains 10 liters of a salt solution. All right, so that's V0 is equal to 10. Water flows into the tank at a rate of 3 liters per minute. Okay, so the rate in is 3 liters per minute. What is the concentration in? Well, it's 0 grams per liter. Why? Because we're pumping in water, so there's no salt, there's no chemical that's going in. And the well-stirred mixture flows out at a rate of 2 liters per minute. So R out is 2 liters per minute. Concentration going out, as always, is M over V. What's V? It's the initial amount you start with, 10, and the difference times T times the difference of the rate in and rate out. So 3 minus 2, that's 1. So C out is M over 10 plus T. Beautiful. Keep going. 2 liters per minute. After 5 minutes, the concentration of the salt in the tank is 0.2. So C of 5 is equal to 0.2 grams per liter. Okay, so this is a little bit different condition that they give us, but we can negotiate that. Remember, concentration is just going to be the mass. So we want the mass at 5 over the volume at 5. Okay. The volume we should be able to find because we have a formula for volume. Okay, after 5 minutes, the volume is going to be 10 plus t, so that will be 15. So the mass at 5 is going to be equal to 0.2 times 15. So that's going to be what? 0.3. Wait, hold on. 15 times 0.2. That's 3. Sorry, off by a decimal. I knew that felt wrong. All right, so the mass at 5 minutes after is going to be 3 grams. Okay, what does the differential equation that we have look like? dm dt is the product of Rn and Cn. Well, that's 0 minus R out and C out. So that's 2 times m over 10 plus t. So that's equal to negative 2m over 10 plus t. In this case, okay, this is a little bit different problem than the ones before it, so maybe we should pursue it a little bit further. Because there's not this, because this term here is 0 and it's not a non-zero term, I don't think we need to use the integrating factor to solve it. Okay, instead, separation of variables might work. We can say this is dm over 2m. Okay, in fact, we don't even need to bring the 2 over. We can say this is dm over m equals negative 2 over 10 plus t dt. That looks right. So this is natural log the absolute value of m equals, and let's integrate this side, negative 2 natural log 10 plus t plus c. Before we can exponentiate both sides, let's write this as 1 over 10 plus t squared. Okay, again, I'm using logs of properties of logs, moving the negative 2 inside the logarithm. Okay, that makes this 10 plus t to the negative 2, which makes it 1 over 10 plus t squared plus c, and that's equal to the natural log of the absolute value of m. Now we exponentiate both sides, and through justifications that we've already made in previous lectures, this ends up being a constant times 1 over 10 plus t squared. So there's mass as a function of t. Okay, the initial condition was given to us that the concentration after 5 minutes was 0.2 grams per liter. But through these set of equations, we have deciphered that to mean that the mass at 5 minutes is 3 grams. Okay, so if I plug in 5 for t, I get to plug in 3 for m. So c times 1 over 10 plus 5 squared. So that's c over 15 squared. That's c over 225. So that means c is going to be equal to 3 times 225. So 3 times 200 is 600. So that's 675 is what c is. All right, so mass as a function of time is going to be equal to 675 times, and I shouldn't even write it as that. It should be 675 over 10 plus t squared. It's a plus sign. There we go. All right. Did we solve the question? No, not necessarily. Find the amount of salt in the tank initially. Okay, so initially, how much salt is in the tank? This is the amount of salt at any given time. The 675 came from the condition of what the concentration of the salt was at 5 minutes. So we want it at 0. So M of 0 is 675 over 10 plus 0 squared. So that's 10 squared. So that's 6.75 grams. Okay. So does that make sense? At time equals 0, there's 6.7 grams of salt in the tank. At time equals 5, there's 3 grams of salt in the tank. So it's less salty after 5 minutes. Does that make sense given the fact that there's just pure water going in? So yeah, of course. After 5 minutes, if we're putting in just pure water and we're pumping out the salty water that's in the tank, of course there's going to be less salt after 5 minutes than originally. All right. Part B. Find the volume of solution in the tank when the concentration is 0.1 grams per liter. Okay, so the concentration, okay, C as a function of time, is going to be M as a function of time divided by V as a function of time. Let's make sure you can see that. There you go. M as a function of time is known to be 675. I should say is believed to be. I'm assuming that all my algebra and calculus is right. 675 over 10 plus t quantity squared. V of t, we established that to be 10 plus t. Okay, so the concentration at any given time is 675 over 10 plus t cubed. And we want to know when that's equal to 0.1 grams per liter. Okay, so 0.1 grams per liter. Let's solve that. If I were to cross multiply, I'd get 675 equals 0.1 times 10 plus t cubed. And if I were to multiply both sides by 10, then I'd get 6750 is equal to 10 plus t all cubed. So take the cube root of 6750, raise that to the 1/3, and that's 18.89, call it 18.9. Is equal to 10 plus t, so t is going to be equal to 8.9. So at 8.9 minutes, the concentration of salt in the tank is going to be 0.1 grams per liter. Does that make sense? Well, if you look at this initial condition that the problem gave us, after 5 minutes, the concentration was 0.2 grams per liter. We're pumping in pure water, so it's going to take longer than 5 minutes for the concentration to be to be 0.1 grams per liter. And how much longer? 3.9 minutes. Yeah, that does make sense. Does it answer the question that was posed to us? What's the volume of the solution in the tank when the concentration is that? And it doesn't. So we need a volume equation here. Volume of 8.9 minutes. After 8.9 minutes, that's going to be 10 plus 8.9 times t, and there's 18.9. All right. Okay, so those are a good, I didn't really intend to do problem number 5, but getting it started, seeing that it's water that's being pumped into the tank, and the initial condition not being initial after 5 minutes I thought that it was worth pursuing uh, the answer from beginning to end instead of leaving it as an exercise for you guys. So really, I'm leaving exercise 2 and 3 for you guys to do. It should look a lot like what the problems look like yesterday, or the problem looked like in the last set of notes. Okay, thanks for coming, and I hope you're having a good evening.